Welcome back to my class. In our last class, we have already solved a few problem sums based on factorization. In today's class also, as I promised in my last class, that I will be solving a few more problem sums based on factorization. So let's get started. These are the problem sums that we will be solving. So let's factorize one by one. Now the first problem sum is this, what you can see here. So what we have to do is, here as we can see in the first term we have this a minus b, this factor, and in the second term we have this x minus y whole square, this factor. And also along with that there is a numeric term, a constant, which is 9. And we know that 9 also can be represented as a square of some other rational number, which is 3. Similarly, 100. In the second term, we can see that we have again a perfect square, which is 100, and that can be represented as square of some other rational number, which is 10. So this term can be represented as 3, then a minus b, and then whole square. So this means 3 square means 9 and a minus b whole square, that was already given in this algebraic expression. And the second term can be represented as 10, then x minus y whole square. So now what comes in our mind is, this resembles one identity that we have already learned, and that is a square minus b square, and that is equal to a plus b multiplied by a minus b. So that can be represented as multiplication of two binomials or two factors. So if we go by this identity, then that can be further written as, so this 3 multiplied by a minus v, that thing can be taken as the whole thing can be taken as our a. So if we now go by this identity, it will be a means 3 multiplied by a minus b, then plus b. So 10 multiplied by x minus y, this whole thing is our b, so it will be plus b. So 10x minus y, and then multiplied by this factor which has this format, a minus b. So here again 3 multiplied by a minus b, the whole thing is our a, so this is a, and then minus b, so 10 multiplied by x minus y. Now what we have to do is, we have to simplify a little more. So if we simplify this, it will be 3a minus 3b, then from here we will have 10x minus 10y. Right, I don't need to explain this. Then in the second factor, what we will have is, we will have 3a minus 3b, and from this term we will have minus 10x, and then minus minus plus 10y. Now in the first factor we have different variables a, b, x, y, so all are unlike terms, we cannot simplify further. And then in the second term also we have all these variables are different, a, b, x, y, so all are unlike terms, so we cannot simplify further. That means this is our simplified answer, or this is the simplified factorized form of this algebraic expression. Next we will try to factorize this algebraic expression, and as we can see, this is similar to the previous one. Here we have xy plus 1 whole square, that format, and we have this numeric value which is 4, which is a perfect square, and that can be written as 2 square. Again 9. In the second term we have 9, which is again perfect square, and that can be written as square of 3. So if we again rearrange the way we did for the first problem, it can be written as 2 and then xy plus 1 and then whole square. And for the second term we can write or rearrange this way, 3 and then x minus y and then whole square. So again what we can see is, this has resemblance with this identity a square minus b square, and that is again a plus b multiplied by a minus b. So this identity already is in the factorization form. This is multiplication of two factors. So if we go by this identity, then we can further write as 2 multiplied by xy plus 1, the whole thing is our a. So it will be a xy plus 1, then plus b. B is what? B is 3 multiplied by this binomial x minus y. The whole thing is our b in our case. So it will be plus b. So 3x minus y. So this is our first factor, a plus b. Then multiplied by a minus b, this factor. So a again 2 multiplied by xy plus 1 and then minus b. So minus b means minus and then this factor 3x minus y. Now what we have to do is, again we have to simplify a little bit. So if we simplify further, then it will be 2xy then plus 2, and then from this term it will be 3x and then minus 3. Then from the second term it is 2xy then plus 2 and then minus 3x and then plus 3. So from the first term we will have 2xy and 3x, they are unlike terms, so we cannot simplify further. So 2xy plus 3x, but these two numeric values, these two constant terms, we can simplify a little bit. 2 minus 3, it will be finally minus 1. So this is our first factor, and then second factor, again xy and x, these two are unlike terms, so we have to write as they are in this factor. So 2xy minus 3x, then we have 2 and plus 3, plus 2 and plus 3, so we will simplify them, so it will be plus 5 now this is the simplified answer, or this is the simplified factorized form of this algebraic expression, because we cannot simplify further. Now we will simplify this algebraic expression, and this will be a bit interesting one. Now this can be further written as x to the power 4 and then square, whole square of that. So 4 and then we have squares. We have already studied in case of exponent that x to the power 4 multiplied by x to the power 4 means their powers will be added and it will be x to the power 8. So from the left side we can write x to the power 4 and then square term, means we have two same factors, same terms. So this is 8, and then for the second term also it can be written as y to the power 4 and then square. Now what we can see is it has this format, a square minus b square, so it will be a plus b and a minus b. I don't need to mention further. So it will be x to the power 4 plus y to the power 4, and the second factor will be a minus b, so it will be x to the power 4 minus y to the power 4. Now from the first factor, what we can do is, it has again the format like x square then whole square. We can rearrange these terms like this. So y4 can be further written as y square then square, and this term is, it can be further written as square then whole square minus y square then whole square. So what we can do is, further the first factor has the resemblance with this identity a square plus b square, and what it is a plus b whole square minus 2ab. So we will go by this identity and we will try to simplify. So this time x square is our a and y square is our b, so it will be a plus b whole square first. So it will be written as x square plus y square a plus b then whole square, and then we have this term minus 2ab. So it will be minus 2, and x square is our a and y square is our b, so it will be written like this. And then in the second factor we have x square whole square minus y square whole square. That means we have this identity, this format, a square minus b square. So it will be further written as, now what we can do is, next we can arrange this factor like this, x square plus y square then whole square, and minus, it has again square terms, x square, y square, and 2, though this is not a perfect square, but 2 can be further written as square root of 2 and then whole square. So this can be further written as root 2 then xy and then whole square. And then from the second factor, what we can do is, we can write x square plus y square, and this term x square minus y square again resembles this identity. So straightforward, I'm writing here x plus y and then x minus y. You may think that x square plus y square, the way I applied the identity for the first factor, because this also had the format x square plus y square. Again here we have this format x square plus y square, but why I didn't apply this simplification rule? because x square y square, that is okay. I can, or we can think this way, that x square plus y square, it will be further or can be written as x plus y whole square, then minus 2xy. And further we can think this way, that x plus y whole square, and 2 means again root 2, and xy means we can think that root x and y, so we can take this way, root x and root y and then whole square. So it again has the format a square minus b square. So we can think that it can be written as x plus y then plus root 2xy. This will be one factor, and then we can further write x plus y and then minus root 2xy, means a x plus y is our a, then plus b, root 2xy is our b, and a minus b. But we will not do this, because here in this factor, in this term, x and y has root value, root x and root y, and similarly in the second factor also, in the third term we have root x and root y. But in the factorization, when we apply the rule of factorization, the rule says that the variables that we will have in those algebraic expressions, there we cannot, the power of those variables cannot be negative or fraction. So it will be always positive and integer, and here we are getting fraction because it is root x, means x to the power half, and y to the power half. Half means 0.5. So it is not integer, though it is positive, but it is not integer. So this rule we have to remember when we will be simplifying with our factorization method. So always the power of those variables will be positive and integer. So we will not apply this rule on this fact. So we will further complete this simplification. We have not done yet. So again it is in this format, a square minus b square. So we will write further, a is our x square plus y square, the whole thing is our a, and root 2xy is our b. For the coefficient part, constant coefficient part, we may have fractional value, but not for the variable. So here it will be a square plus b square, means x square plus y square and then plus root 2xy. So this will be our one of the factors from this, and then a minus b. So x square and then plus y square, this will be our a minus b. So it will be minus root 2xy. So this will be our second factor. As I said, x square plus y square we will not factorize further, so it will be as it is, and then we have obtained this x plus y and then x minus y. In this simplification, finally we have obtained 5 factors, and in each factor this x and y, the power of x and y are positive and integer. So till then we have simplified, and now from these 5 factors we cannot further simplify, we cannot increase the number of factors. So this is the simplified answer for this algebraic expression. I hope you have understood what I explained. Now in the next problem sum, we will again factorize this algebraic expression, and this looks easier than the previous one. We have x to the power 4 and y to the power 4, and here we have this numeric value which is again a perfect square. So this can be further written as, so it has the format a square plus b square, so it can be further written as, so it will be 2x square plus y square whole square, and this will be minus 4x square and y square, and this again can be represented as a square of some other term. Let's see what it will be. It is already in the square form, 2x square plus y square and then whole square, and 4 is also a perfect square, x and y, so x square and y square, so it can be further written as 2xy and then whole square. And here x and y, inside the square, this term we have those variables x and y, and their powers are positive integer 1. So till this point we can simplify this way. Now it has the format a square minus b square, so it will be, from here we cannot simplify further, so this is our simplified answer. Now next and the last problem is this. So we will try to simplify this 16, so we will keep 16, and 16 is also a perfect square. Now from here what we can see is we have a to the power 6 term. Okay, a to the power 6 is again perfect square, so this can be represented as aq then whole square. Then here we have this term 4b to the power 6, and this is also a perfect square. So 4b to the power 6 further can be written as or represented as 2, then bq, and then whole square. So 2 square means 4 and bq square means b to the power 6. And here we have aq and bq term. So apparently it looks that if we take this way, that aq whole square, then this, then square of that bq whole square. So in the 2ab factor, if whether it is plus 2ab or minus 2ab, we will have aq and bq term. So let's think that way and let's try to rearrange that way, because we already have 16 here and 16 is a perfect square, so it can be represented as 4 square. So what we will do is, here the first term, this a to the power 6 term is negative and this also negative, so we have to take minus 1 common. So if we do that, then inside the bracket we will have a to the power 6. This factor will be negative now, so 4 aq bq, and this term or factor will be plus 4b to the power 6. Now 16, let's write that 16 only, and let's fit this part of this algebraic equation with an identity. So a to the power 6 can be written as aq square, then we have 4b to the power 6 terms, so that can be further written as 2bq then whole square, and here we have 4aq bq. So if we further write this way, minus 2 and then aq and then 2bq, right? We can write this way, so 2 and 2 4 aq and this bq, so finally it is minus 4aq bq only. So that means it resembles what? It resembles aq means our a, so a square, 2bq is our suppose b, so b square, and then minus 2ab. So it will be aq minus 2bq and then whole square. So now what we can see is 16, which is a perfect square. If we represent this way, 4 square, and here also we have aq minus 2bq whole square. So we have this format, a square minus b square. So it will be what? 4, which is a, then plus a means aq minus 2bq in our case, so a plus b, and then a minus b, so 4 minus b is what? aq minus 2bq, that is the whole thing is our b this time, so a minus b. So we have to simplify a little more, and then after simplification we will have 4, then from here aq minus 2bq in the first factor, and in the second factor it will be 4 minus aq plus 2bq, and in both the factors we have all the terms are unlike terms, so we cannot simplify further. So this is our most simplified factorized form of this algebraic expression. I hope you have understood this problem sums what I have solved in today's class clearly. In future you will be able to solve these types of problem sums. With that hope, I end today's class. Thank you.